In our last section of chapter 5, we'll be graphing inequalities. So if you remember how to graph equations, there's just a couple extra steps we have to do. They're not difficult, they're just things you have to remember. But let's look at the first the first example. I love how I open so many videos with coughs. Anyway, so it says graph y is less than or equal to negative 3x plus 2. So just as this says, the first step is just to graph negative 3x minus 2. Now you can do this by finding x and y intercepts. You can do this by graphing or using a table. What I'd recommend though is anytime they give one of these to you, make sure it's in slope-intercept form, and then graph the y-intercept first. Wrong pen, sorry. Y-intercept first, which is negative 2. So you can see over here, they put a point at negative 2 on the y-axis, because that's what the y-intercept is. And the slope is negative 3. So from that point, you can either go down 3 and over 1, or you can go up 3 and to the left 1. Now, since this has an or equals to, that means you do a solid line. So that covers the line part. But as you can hopefully see, this side is darker than this side. That's because when we have an equation, we have an exact line that fits it. But when we have an inequality, we not only have the line that serves as the boundary, but then we've got to decide, well, which side of the line is this true for? Now we've done that with inequalities, which is one variable, by saying like, oh, y is less than negative 4. So we put an open circle at negative 4 and shade it to the left. But here we've got two dimensions to think about. So here's what you do. Now they chose two different points. You're welcome to just do 1 point, but I want to show you what they chose. They chose 0, 0. So the point is, you have to pick a point that's not on the line. Now I would recommend 0, 0 because it's an easy one, unless it's on the line. So once you pick a point, which their first point was 0, 0, they plugged 0, 0 back in this original equation. They plugged in 0 for x and 0 for y. So you can see that work down here. They plugged in 0 for x. They plugged in 0 for y. Then they evaluated what they have. Well, that's just 0. Negative 3 times 0 is 0. 0 minus 2 is negative 2. So then you have to look at this right here and say, okay, is this true or is this false? Well, 0 is not less than negative 2. So this is false. So this is the point 0, 0. We just found out that is a false statement that creates for this inequality. So that's what led us to shade this side instead of this side. So you're only required to check 1 point. If it's false, shade the side of the line that's not on that side. If it's true, like it is when they plug in negative 2, negative 2, they plug in negative 2 for x and negative 2 for y. They get positive 6 minus 2, which is 4. And negative 2 is less than 4. So negative 2 is down here. Sorry, right there. That's a true statement. So that tells us that the left side of the line is what's true. So we shade the left side of the line. So here are our steps. Step 1 is to draw the line, just as you've learned before. Find the y-intercept, graph that point, then use the slope to find a second point, and draw a line through those 2 points. It should be a solid line if we have an or equals to with inequality. It should be a dotted line if we just have less than or greater than. So that helps you draw the line. Then you can just pick 1 point, just make sure it's a point that's not on the line you just drew. Plug it in to the original inequality. If the result is true, shade on that side of the line. If it's false, shade on the other side of the line. Now I know this is brand new, but if you'll just make sure you are watching these steps as we go through it, I think it'll make sense. So on this one, we have to remember that anytime it's just y and a number, it's a horizontal line. So this is a horizontal line at 4. So 1, 2, 3, 4. And there's no or equal to, so I'll do a dotted line through positive 4. So I've covered step number 1. I've drawn the line. At step number 2, I made it dotted because there is no or equals to in this. Now personally, I tend to pick 0, 0 anytime I'm able to do so. So if I plug in 0 for x, well, there is no x. But if I plug in 0 for y, so I plugged in 0 for that y because I'm looking at this point right here. You don't have to mark this. I'm just doing it to try to help you as I teach you. Plug in 0 for y. Well, 0 is in fact less than 4, which means that's a true statement. So since this point gave me a true result, I will shade it on this side of the line. This next one, just like when you have y and a number, you have a horizontal line. When you have x and a number, you have a vertical line. So here's 1 on the x-axis, and this says or equal to, so we put a solid line through x equals 1. So just as I did before, I'm going to choose 0, 0 as my test point. That's this right here. If I plug in 0 for x, I get 0 is greater than or equal to 1. Ah, that is not true. 0 is not bigger or equal to 1. So that means this side of the line is false. So instead of shading to the left side of the line, I have to shade to the right side of the line. Okay, on number 3. Now this is sort of in slope-intercept form already, except we want the y to be on the left side. So just as we talked about when we were graphing on lines, we want the variable to be on the left. We'll also want the y value, if there is one, to be on the left. So we can rewrite 3x is less than or equal to y as y is greater than or equal to 3x. So remember, the slope is always the number in front of the variable. So the slope is the 3. The b is always the constant that's out here after it, but there isn't one. So that means the y-intercept this time is 0. So this line, y is greater than or equal to 3x, crosses through the origin. The y-intercept is 0. Now from there, we say, okay, since the slope is 3, which I can write as 3 over 1, to find the next point, I'd go up 3, 1, 2, 3, and over 1. Then I can draw a line through those 2 points. And I did a solid point because it's got an or equals to in the problem. So this time I can't pick 0, 0 as my test point. That's okay. I'll just pick 1, 0, which is this point right here. And you can plug it in this version of the equation or this version. It will make no difference at all. I'll just plug it in this one since this is what we started with. So I plug in 1 for x, and I plug in 0 for y. So this says 3 is less than or equal to 0. That's not true. 3 is not smaller than 0. So this point I picked over here is false. So I would not shade this side because it results in false answers. Instead, I would shade on this side. Okay, number 4 is already in slope-intercept form, which is nice. My slope is the number attached to x, which is negative 1/2. My y-intercept is negative 3 because it's the constant that's not attached to the x. So when I'm graphing, I start with my y-intercept. So I count down on the y-axis to 1, 2, 3. And then the slope is negative 1/2. So I can go down 1 and over 2, or I can go up 1 and to the left 2. Either way, that gives me the correct direction. And since there's no or equals to, I'll have to draw a dotted line through these points. So we've covered step 1 and step 2. We've drawn the line, And we made it dotted because it's a less than. And then I'm going to choose 0, 0 as my test point again. So I'm testing this point right here. I plug in 0 for x. And I plug in 0 for y. So this piece just cancels out. So I get 0 is less than negative 3. But as you hopefully know, 0 is not smaller than negative 3. So this side of the line is false because that point gives us a false result. So instead of shading above the line, we'll shade below the line. Okay, now 5 and 6 will take a little bit more work because we want these to be in slope-intercept form. So let me write this down here and we'll work to make that happen. So I want the y by itself here on the left side. So I'll start by subtracting 4x. Gives me negative 3y is less than negative 4x plus 6. Then I will divide every piece here by negative 3. Now this is an inequality. Since I divided by a negative number, I have to flip the inequality sign and make it greater than. And negative 4 over negative 3 is positive 4 over 3. 6 over negative 3 is negative 2. So as I'm trying to graph this, I start with a y-intercept, which is this number by itself, the constant, negative 2. So I know that point exists on the graph. Then to find a second point, I use this 4/3, because that's the slope. The number attached to the x, the coefficient of the x, is the slope. So we go up 1, 2, 3, 4, over 1, 2, 3. Now since this does not have an or equal to, I'll draw a dotted line through those 2 points. And I can pick 0, 0 again, because that does not lie on the line. So I'll plug in 0 for x and 0 for y. Well, this piece cancels, so I get 0 is greater than negative 2. Hey, that's true. 0 is greater than negative 2. So that means the point I plugged in is true, so I want to shade the line on that side. Okay, last one. Again, this is not in slope-intercept form, so we'll need to make it so it is. So I'll start by subtracting 3x from both sides. My goal is to get the y by itself on the left side. And then I'll divide everything by 6, every single piece by 6. Now, since this is a positive 6, I don't have to flip the inequality sign. I'll keep it as y is greater than or equal to. Negative 3 over 6 is the same as negative 1/2. 12 over 6 is the same as 2. So my y-intercept is the constant, the number by itself, 2. My slope is negative 1 over 2, so I go down 1 over 2. You can do it again if you want, down 1 over 2. So it's going to be a solid line through those points. And it's solid because it's a greater than or equal to situation. Anytime it has an or equal to, it's a solid line. So I'm going to pick 0, 0 again. Plug in 0 for x. Plug in 0 for y. This piece cancels out, so we get 0 is greater than or equal to 2. That's not true. 0 is not bigger than 2. So that means this side of the line is false, because when I plug that in, I get a false result. So instead I'll graph the other side of the line.